Hi guys, welcome to Prof K YouTube channel. So today we are still on vectors. So today we'll be dealing with linear combination of vectors. So we'll be dealing with linear combination of vectors. So let's say we have v equals to, this is alpha 1, alpha 1, alpha 1, alpha like this. So this is v equals to alpha 1 v1 plus alpha 2 v2 plus and so on plus alpha n vn. Satisfying this relation now, we want to derive the formula for linear combination of vectors. That will give us alpha 1 v1 plus alpha 2 v2 plus and so on, depending on how many vectors they give you, plus alpha n vn must all be equals to what? 0. Must all be equals to 0. Under linear combination of vectors, it's just two things we are always showing for. Either it is linearly dependent or linearly independent. Either it is linearly dependent or linearly independent. But we'll not be using this formula to save time. So we'll just use the short method. That's the determinant method. You get. So this question is always common in written exam. So they will just tell you to show that it is linearly dependent or show that it is linearly independent. So what is it all about? Linearly dependent, when they say something is linearly dependent, it shows that when you solve the determinant of that stuff, of that vector, when you solve the determinant of that vector, it must give you what? 0. So if they say you should show that this vector is linearly dependent, it shows that when you solve the determinant of that vector, it must give you 0. But if they say that you should show that it is linearly independent, it shows that when you solve the determinant, it must not be equal to what? 0. It must not be equal to 0. You can have any value. You can have plus some so, or you can have minus so. But it must not be equal to 0. That's why. But if you have to use this formula, it's a little bit long, where you have to what? Expand, take coefficient. You get for alpha 1, you get for alpha 2, you get for alpha 3, and so on, depending on how many vectors they give you. You get. So that's why I said note, the set n vectors v1, v2, and so on to vn is said to be linearly dependent if a set of n scalars, alpha 1, alpha 2, and so on to alpha n, such that all of them are not 0. That's if you are using this formula, such that all of them are not what? 0. It means that when you solve for linearly dependent, it shows that your alpha 1, alpha 2 must not be equal to what? 0. But if all the scalars are 0, that is alpha 1 is equal to alpha 2 is equal to alpha 3 and so on to alpha n is equal to 0, then the set of n vectors v1, v2, v3, and so on to vn is said to be linearly independent. But if you have to use this formula, you have to start expanding, taking coefficient. But let's just use the determinant method. If you understand matching very well, you are good to go. So we'll just be solving 2 examples. So I'll solve one in this video, then the next video you check for another one. So example 1, if R1, this is R1, vector R1 is equals to J, this is J minus 2K, comma, vector R2 equals to I minus J plus K, and vector R3 equals to I plus 2J plus K. Show that the set of vectors R1, R2, R3 are linearly independent. And don't forget, we are not using this formula here. We are not using this one. But we just want to use the determinant one. So don't forget, when I said when it is linearly independent, your determinant must not be equal to 0. But if they say it is linearly dependent, your determinant must be equal to 0. So let's just be fast about this question. So we are given R1 as J minus 2K. We are given R2 as I minus J plus K. And we are given R3 as what? I plus 2J plus K. I plus 2J plus K. Now, let's just use the determinant method. You know it is in form of, let's say, I, J, K. I, J, K. For R1, do we have I for R1? No, we don't have I. So what's the value for I? 0. What's the value for J? 1. What's the value for K? Minus 2. Abi? For R2, what's the value for I? 1. Value for J? Minus 1. Abi? You have to take with the sign. Minus 1. Then K is what? 1. Then for R3, what's the value for I? 1. What's the value for J? 2. Abi? And what's the value for K? 1. So, this is it. So, on top of it, we put plus, minus, plus. Plus, minus, plus. On top of it, just put plus. You know how to solve 3 by 3 determinant now. So, now, let's go. You know, yeah, the first thing is what? Plus 0. So we are reducing a 3 by 3 to 2 by 2. So in this question, I'm trying to solve for determinant also. Now, let's do it like this. So we have 0, 1 minus 2, 1 minus 1, 1, and we have 1, 2, 1. Now, this is the 0 I'm picking. This is the 0 I'm picking, plus 0. Now, cancel to the row. You know this is the row. Horizontal is the row. Cancel to the column of that 0. Cancel to the row, cancel to the column of that 0. What are we seeing? We are seeing what? Minus 1, 1, 2, 1. So we'll be seeing minus 1, 1, 2, 1. Abi? Shall you get? Minus 1, 1, 2, 1. So the next thing, what are we picking? Minus 1. Minus 1. So we have, let's write it 0, 1 minus 2, 1, 1. This is the one I'm picking. You know, this is the one on top. I'm writing the minus and the 1. This is the one I'm picking. Cancel to the row of that one. Cancel to the column. To the row and to the column. What are we seeing? 1, 1, 1, 1. So we'll be seeing what? 1, 1, 1, 1. Abi? Shall you get? So the next thing is what? Plus. You write plus, the 1. Then here is what? Minus 2. Let's put it inside bracket. So let's do it again. We have 0, 1 minus 2, minus 1, 2. Now, this is the minus 2 I'm picking. Abi? The minus 2. Cancel to the row of that minus 2. Cancel to this column. To the row of that minus 2 and to the column. What are we seeing? 1 minus 1, 1, 2. We'll be seeing 1 minus 1, 1, 2. 1 minus 1, 1, 2. Shall you get? So now, we have already actually reduced a 3 by 3 to 2 by 2 determinant. So now, how do you solve 2 by 2 determinant? It's just simple. Cross multiply. It's just like this multiply by this, then minus. It's always minus. This multiply by this, then minus this multiply by this. This multiply by this, then minus this multiply by this. This multiply by this, then minus this multiply by this. That's how you solve a 2 by 2 determinant. So we'll be having 0 into bracket. Here will now be minus 1 times 1. Abi? Minus 1 times 1, then minus 1 times 2. Minus 1 into bracket. Here will now be 1 times 1 minus 1 times 1. Plus times minus 2 will give us what? Minus 2. So here will be 1 times 2, Abi? Then minus 1 times 1. Here is 1 times 2. You know the sign in between is always minus. Then here is now having minus 1 again. That's why I put inside bracket. Minus 1 times 1. So here will now be giving us what? 0 into bracket. Minus 1 times 1 will give us what? Minus 1 minus 2. Then minus 1 into bracket. 1 times 1 is what? 1 minus 1. Then minus 2 into bracket. 1 times 2 is what? 2 minus. Minus 1 times minus 1 will give us what? Minus 1. So we'll put inside bracket. So what are we having? We'll be having 0 into bracket minus 3. Minus 1 into bracket 0. Then minus 2 into bracket 2 plus. You know, minus and minus will give us what? Plus 1. 2 plus 1. So 0 times minus 3 will give us what? 0. Abi? Minus 1 times 0 is what? 0. Then minus 2. Minus 2 into bracket what? 2 plus 1 is what? 3. So what is it going to give us? That will be giving us minus 2 times 3 will give us what? Minus 6. So you see that after solving the determinant of this guy, we are now having 0. So it shows that what? You can now say therefore. You can say therefore, the set of vectors R1, R2, R3 are what? Are linearly independent. So it shows that the set of vectors R1, R2, R3 are what? Are linearly independent. So please, we'll be solving another question based on linearly dependent. So do well to subscribe and check for the next video. Like and share this video. Thank you.